So mean free path. Okay, mean free path means listen. For example, this is one small particle. It is moving to one particular end. Again, it is after the collision, it is turned back in this direction. Again, it is going to the. I will mention the point A. This is the origin starting point. A, B, C. Again, in this end, D, and this one E. Mean free path: the average distance traveled by the molecule between two successive collisions. Between two successive collisions. Again, I will repeat. Average distance traveled by the molecules between two successive collisions and is measured as the mean of large number of free paths. This is a large number of free paths. That is a two successive collision. For example, O to A, the distance it is there, no? That is a lambda 1. Again, A to B, lambda 2, up to lambda n. Then the average lambda bar equal to lambda 1 plus lambda 2 plus lambda 3 plus etc. divided by the total number of collision. Okay, this is the mean free path formula. Lambda bar equal to lambda 1 plus lambda 2 plus lambda 3 up to lambda n. Total number of divided by total number of collision. Some assumption it is the first one, the gas molecule is perfectly spherical in the shape. Always see that I put only the round. It is not a like a square shape, otherwise triangle like this. It is only the spherical in the shape. Next one, all the gas molecule of a gas exhibit one under the condition of rest. Mhm. For example, consider to the particle at rest. Okay, it is start with moving during the successive collision. Then only we can calculate the entire path. Otherwise, always it is roaming means we feel it is difficult to measure. So start from rest. So easy to calculate the average distance. Okay, based on that, one small derivation it is there. That one we'll discuss. So based on the assumption, consider 1 minute. I will complete the diagram. I will take three molecules for example purpose 1, 2, and 3. The distance for the one molecule, that is d, and it is moving velocity v, uh, one particular place to another place. For example, A to B. I need to calculate the length, that means the distance, velocity into time, and the area pi d square. So one sample of gas having n molecules per unit volume of the gas, n number of molecules per unit volume of gas, and the moving velocity v, the diameter d, length v into t, so that n equal volume of cylinder of the length vt, volume of the cylinder length, and the area of the cross section pi d square, number of molecules per unit volume, that is n, number of molecules per unit volume. So n equal pi d square into Vt into n. Now I am using the mean free path formula, lambda formula. Lambda bar equal to distance covered by molecule in time t, number of oscillation. Lambda bar equal to the total distance it is v into t, that is the length, divided by number of oscillation. Now only we calculate, that is a capital N, pi d square Vt into n, and Vt cancelled. I will get lambda bar equal to 1 by pi d square n. Okay, now. So used in this formula, we can calculate the lambda bar, mean free path of a gas molecules. It is Maxwell law of distribution of velocity based on formula. Just to note the formula alone, lambda bar equal to 1 divided by root 2 pi d square n. And one more formula, it is related to density. Lambda bar equal to small m divided by root 2 pi d square divided by rho. Kindly note in these two formulas now. Okay. So almost we completed all the topics now. There is no bending. So it is a kinetic theory of gas. First one, the behaviors of gas, ideal gas equation PV is equal to nRT, and the relation, the Boyle's law, Charles law, Gay-Lussac's law, the universal gas constant formula, R formula. Some difference also there. Please note it. End of the class, I will share you the notes. You can download. Next, Boltzmann constant, Kp equal to R by N, and the value of Kp 1.38 into 10 power minus 23 joule Kelvin inverse. The ideal gas equation, another one related to density, kinetic theory of gas, assumption, root mean square formulas. Yesterday we discussed in this related problem also. Average speed, degree of freedom, F is equal to, here they mention 3a minus r, we mention 3n minus k, whatever may be, you can utilize, no problem. Monatomic gas, diatomic gas, triatomic, non-linear, linear, law of equipartition of energy, specific heat capacity, specific heat constant pressure. It is extra formulas, the mixture of gas. In case they are giving me, you can utilize in this formula. Now we discuss mean free path. Lambda equal to total distance traveled by a gas molecules. between successive collision, total number of collision. The ratio for Vrms, V average, Vmp, that is a root 3 is to root 2 2.5 is to root 2. Some important values. Okay, we'll try in this problem.